Okay, welcome back everyone to our statistics class notes here in section 9.3, where we're talking about how to construct confidence intervals for population means, and we are on page 146. Okay, so everything we've done now is going to lead us to how we can compute the one sample t interval, confidence interval. So the one sample t interval is a confidence interval for a population mean. So it's of the form x bar plus or minus m, so that's our estimator, x bar, our statistic, our sample mean, plus or minus m. Or if I write in interval notation, it's x bar minus m to x bar plus m. So in other words, we have x bar in the middle of our confidence interval, and we go a margin of error to the left of it, we subtract m, and we get the left side of the confidence interval, the lower limit, which is x bar minus m. And the right side of the confidence interval, or the upper limit, is x bar plus m. So recall, that's the same like doing a confidence interval for a population proportion. That makes the width of the confidence interval 2m, right? Two margins of error, because it's one margin of error to the left and one margin of error to the right. Where now this margin of error m is our multiplier, which is now going to be denoted as t star times the standard error estimate. And the standard error estimate is s divided by the square root of n. Now the multiplier t star is found using what's called the t distribution with n minus 1 degrees of freedom. This t distribution we talked about at the very end of section 9.2. It's a distribution that looks very much like a normal distribution. It's just that it slightly changes, the curve slightly changes depending on each sample size, and is called, so your sample size is n. So the degrees of freedom is just a fancy mathematical name for how many degrees of freedom that we have based on our sample size. It's always one less than the sample size. If you remember when we constructed the sample standard deviation by hand, and I asked you not to do that very often, you look at the differences of all the, you take x bar minus each x value, and then you square it, each one of those, and add them all up, and then divide by n minus 1 before you take the square root of the whole thing. So that's because it was degrees of freedom, but none of that's really important for you. All I need you to remember is that t star comes from something called the t distribution with n minus 1 degrees of freedom. Now, we're not going to be having a table of these t stars like we did for the z stars. Remember, z star was 1.96 if we wanted a 95% confidence interval for a population proportion. It was 2.58 if we wanted a 99% confidence interval for a population proportion. So the t star is not going to be having, it changes for every single sample size. So we're just going to let StatCrunch find these values, and really we don't need them. I'm going to show you below how you could find the t star if you were ever asked to find it, but you don't necessarily need it to construct the confidence interval, because we're going to use StatCrunch to do that. So how to construct a one sample t interval. You need the following four pieces of information. You need the sample mean first, so we get that from our sample, of course, x bar. We need the sample standard deviation, get that from our sample, that's s. We need to know the sample size, n. And technically we would need to know the multiplier t star, but we will use technology, StatCrunch, to directly incorporate that into our confidence interval. So remember that t star is determined by the confidence level and the sample size in this case. So although we will not find it directly, it's a very important piece of the confidence interval for a population mean. So, but I'm not going to be saying you should memorize what the t stars are. The value of t star would tell us how wide the margin of error is in terms of the number of standard error estimates, right? Because it's the margin of error is t star times the standard error estimate. So it tells you how many standard error estimates wide the margin of error is. For example, if t star is 2, then our margin of error is 2 standard errors wide. Okay? All right, now let's go through this example of doing it. I'm going to go and save this for the next video though.